In this video, we'll solve the October-November 2023 question paper 53 for the CIE A Level Maths 9709 exam board. This is Probability and Statistics 1. Subscribe and let's get into it. Number 1. Becky sometimes works in an office and sometimes works at home. Random variable x denotes the number of days that she works at home in any given week. It is given that the probability that x equals x is equal to kx times x plus 1, where k is a constant and x equals 1, 2, 3, or 4 only. Draw up the probability distribution table for x given the probabilities as numerical fraction. Okay, so we have been given the function that we can use to evaluate the probabilities. So let's start by evaluating the probability that x is equal to 1. So that becomes k. Wherever there's an x, substitute with 1. So this becomes 1 plus 1 inside the brackets. And so this simplifies to give us 2k. And we'll do the same for x equals 2. So this becomes k times 2 times 2 plus 1, which gives us 6k. And then we do the same for x equals 3. That's k times 3 times 3 plus 1, which is equal to 4 times 3, which is 12k. And we do the same for when x is equal to 4. So that's k times 4 times 4 plus 1. So that's 5 times 4, which is 20k. Now these are the probabilities for x equals 1, 2, 3, or 4, but notice that our probabilities are in terms of k, and the question says that we should give them as numerical fractions. This means that we have to evaluate k. We know that all the probabilities for the random variable should add up to 1. So that's 2k plus 6k plus 12k plus 20k. This should equal 1. So if we simplify this, 2 plus 6, which is 8, plus 12, which is 20, plus 20, which is 40. So 40k is equal to 1, and therefore k is equal to 1 over 40. So now let's draw up our probability distribution table. So we've got x and probability that x is equal to x. Let's draw a line over here. And then we've got when x is 1. When x is 1, it's 2 times k. So that's 2 over 40. 2 over 40 because our k is 1 over 40. And then when x is 2, that's 6 over 40. Then when x is 3, that's 12 over 40. And then when x is 4, that's 20 over 40. And this would be our probability distribution table. Let's just draw the outer lines so that it looks like a table, and that will be your final answer. Part B. Find expectation of x and variance of x. Okay, so the formula for expectation of x is equal to the summation of x times p. So this becomes 1 times 2 over 40 plus 2 times 6 over 40 plus 3 times 12 over 40 plus 4 times 20 over 40. Now let's punch this into a calculator. That's 1 times 2 over 40 plus 2 times 6 over 40 plus 3 times 12 over 40 plus 4 times 20 over 40. And this gives us 13 over 4. So this is 13 over 4. And now we need to find the variance. So var of x, the formula in the MF19 is summation of x squared p minus the expectation of x squared. So we already have the expectation. Now let's find the summation of x squared p. So this is summation of x squared p. It's basically this whole expression, but the x is squared. So that will be 1 squared times 2 over 40 plus 2 squared times 6 over 40 plus 3 squared times 12 over 40 plus 4 squared times 20 over 40. Punch that into the calculator. So that's 1 squared times 2 over 40 plus 2 squared times 6 over 40 plus 3 squared times 12 over 40 plus 4 squared times 20 over 40, and that gives us 227 over 20. 227 over 20. Let's substitute into the formula for var of x. So that becomes 227 over 20 minus the expectation squared, that's 13 over 4 squared. Var of x is equal to, let's punch this into a calculator, that's 227 over 20 minus 13 over 4 squared, which gives us 63 over 80, and this would be our final answer. Number 2. The weights of large bags of pasta produced by a company are normally distributed with mean 1.5 kgs and standard deviation 0.05 kgs. Part A. Find the probability that a randomly chosen large bag of pasta weighs between 1.42 kgs and 1.52 kgs. Okay, so let's define our random variable x, and that's the weight in kgs of large bags of pasta. Large bags of pasta. And then x follows a normal distribution as we're told in the stem, with mean 1.5 and standard deviation 0.05, so squared for variance. And we are looking for the probability that a randomly chosen large bag of pasta weighs between 1.42 and 1.52 kgs. So 1.42 x 1.52. Let's standardize, so that will be 1.42 minus 1.5 over sigma, which is 0.05, and that's z, that's 1.52 minus 1.5 over sigma 0.05. Let's punch that into the calculator. That's 1.42 minus 1.5 over 0.05. So that's negative 1.6. Negative 1.6 is less than z, which is less than 1.52 minus 1.5 over 0.05, which gives us 0.4. So we can write that as phi of 0.4 minus 1 minus phi of 0.6. And then we can use our normal distribution tables. So this becomes 0.6554 minus 1 minus 0.9452. And let's punch that into the calculator. 0.6554 minus 1 minus 0.9452. And that simplifies to give us 0.601. And that's our final answer. Let's move on to part B. The weights of small bags of pasta produced by the company are normally distributed with mean 0.75 kgs and standard deviation sigma kgs. It is found that 68% of these small bags have weights less than 0.9 kgs. Find the value of sigma. Okay, so again, our random variable is the weight in kg of, this is now small bags of pasta, and we are given that this is normally distributed, so y follows a normal distribution with mean 0.75 kgs, and we're given that the standard deviation is sigma. We are told that 68% of these small bags have weight less than 0.9 kgs. So the probability that y is less than 0.9 kgs is equal to 68% or 0.68. So we can use our tables in reverse to evaluate the z value. So 0 would be somewhere here. 68%, if we draw a line here and say this is our z value, we're saying this area there, the shaded region, is equal to 0.68 or 68%. So if we were to standardize this expression over here, it would become the probability that z is less than 0.9 minus our mean, which is 0.75, and this is all over sigma, right? And we're saying that this expression over here is equal to the z value we'd get over there. So z is equal to 0.9 minus 0.75 over sigma. So let's first simplify that. That z is equal to 0.15 over sigma. Now let's use our tables in reverse to evaluate arc-phi of 0.68. That should give us our z value. And the z value we should get is 0.468. So that means 0.468 is equal to 0.15 over sigma, which leads to sigma is equal to 0.15 over 0.468, and therefore sigma is equal to, we punch that into the calculator, that's 0.15 over 0.468, that gives us 25 over 78, and that's our final answer. Number 3. Tim has 2 bags of marbles, A and B. Bag A contains 8 white, 4 red, and 3 yellow marbles. Bag B contains 6 white, 7 red, and 2 yellow marbles. Tim also has an ordinary fair 6-sided dice. He rolls the dice. If he obtains a 1 or 2, he chooses 2 marbles at random from bag A without replacement. If he obtains a 3, 4, 5, or 6, he chooses 2 marbles at random from bag B without replacement. Part A. Find the probability that both marbles are white. Okay, so we've got bag A and bag B. In bag A, we've got 8 white, 4 red, and 3 yellow marbles. And in bag B, we've got 6 white, 7 red, and 2 yellow marbles. And we're told that Tim has an ordinary fair 6-sided die. This should be die because it's singular. But anyways, Tim rolls the dice. If he obtains a 1 or a 2, he chooses 2 marbles at random from bag A. So if he rolls 1 or 2, he chooses bag A. And then if he rolls a 3, 4, 5, or 6, he chooses bag B. 3, 4, 5, or 6. And we want to find the probability that both marbles are white. So we want the probability of a W on the first pick and a W on the second pick, as well as in bag B. So we can say that the probability of 2 whites of 2 W's is equal to picking bag A followed by picking 2 W's in bag A, and then we could also pick B and 2 W's. So when we pick bag A, the probability of picking bag A was saying he has to roll either a 1 or a 2 out of 6 possible outcome. So that's 2 over 6. And then to pick a white in bag A, we have 8 white marbles. That's 8 out of a total of 15 marbles. 8 plus 4 plus 3 gives us 15. And then since this is sampling without replacement, to pick the second white, it means only 7 white marbles will remain after you pick the first white. And therefore we have a total of 14 marbles remaining. So that means this becomes probability of 2 whites is equal to 2 over 6 times 8 over 15 times 7 over 14 plus the probability of picking bag B, that's 1, 2, 3, 4 out of 6, 4 out of 6. Then the probability of picking the first white in bag B would be 6 out of 15, 6 out of 15. Then since we've picked one white, 5 will remain, and that's out of a total of 14. So this becomes 4 over 6 times 6 over 15 times 5 over 14. Now let's punch that into the calculator. Let's see what we get. That's 2 over 6 times 8 over 15 times 7 over 14 plus 4 over 6 times 6 over 15 times 5 over 14, and that gives us 58 over 315. So that's 58 over 315, and this is our final answer. Part B. Find the probability that the 2 marbles come from bag B given that one is white and one is red. So this is conditional probability, and our formula is the probability that B given A is equal to the probability of A intersection B over the probability of A. So in this case, A is our given event, given that one is white and one is red. So 1 W and 1 red. And then B is the marbles come from bag B. So that's bag B. And then the intersection A intersection B is we have to pick bag B, and we should get 1 white, 1 red. So we need to find the probability of A intersection B, which is the probability of picking bag B. We evaluated that picking bag B, there is a 4 in 6 chance of picking bag B, and then we also have to pick 1 white and 1 red. Okay, so that's a 4 in 6 chance of picking bag B. Now let's find out the probability of picking 1 white and 1 red after picking bag B. So let's just write it down here so that is a bit clearer. We've got B having 6 W, 7 reds, 2 yellows, and we want to pick 1 white and 1 red. So we could either pick the white first or the red first. So let's consider both scenarios. That's the probability of bag B followed by a white marble and a red marble, or the probability of bag B followed by a red marble first and then a white marble. So that would be probability of picking bag B, we say that's 4 over 6 times W being white, we have 6 of them, so that's 6 out of 15. And then only 14 total marbles will remain since it's sampling without replacements. And then how many reds do we have? We've got 7. And then the other scenario where it's bag B, red, then white. So red is 7 out of 15. Now we have a total 14 marbles left, and we want to pick a white, that's 6 out of 14. So this, if you punch this into your calculator, you should get 4 over 15. So let's go down here. We can erase this. So this would become 4 over 15. And then now let's find the probability of A. So the probability of A is the probability of picking one white and one red. So we can either pick peg A followed by one white, one red, and then pick peg A again followed by one red and one white, or we can pick peg B followed by a white and a red plus peg B followed by red and a white. So the last two scenarios, you notice that these are basically probability of A intersection B. So probability of A can simply be written as the probability of peg A white red plus peg A red white plus the 4/15. So now let's evaluate the probability of picking peg A. Peg A, we say it has got 8 white, 4 reds, and 3 yellows. 8 whites, 4 reds, and 3 yellows. And there's a 2 in 6 chance of picking peg A. So we want the probability of white of peg A, white, red, or the probability of peg A, red, white. So this becomes 2/6 times white. We've got 8 of them out of 15. Since we've removed one, only 14 remain, and we're 4 reds, so that's 4/14. Plus this becomes 2/6 times red. We've got 4/15 times white, which is 8/14. Let's punch that into the calculator. That's 2/6 times 8/15 times 4/14 plus 2/6 times 4/15 times 8/14, and that gives us 32/315. 32/315. Let's go back down here. So this becomes the probability of A is equal to 32/315 plus 4/15. And if we add those two together, we get 116/315. 116/315. And now let's go back to our formula for conditional probability. So the intersection A intersection B is 4/15 divided by the probability of A, which is 116/315, and this gives us, that's 4/15 divided by 116/315. This gives us 21/29. Probability of B given A is equal to 21/29, and that's our final answer. Number 4. The weights X kilograms of 120 students in a sports college are recorded. The results are summarized in the following table. Part A. Draw a cumulative frequency graph to represent this information. Okay, so let's start by labeling our y-axis as cumulative frequency. And then our x-axis would be, that's weight in kilogram, weight in kg. Alright, let's go back here. And from our classes, we can tell that they start at 40 going onwards. So what we can do is we can label our x-axis in intervals of 10. So I'm just going to label this as 0, then we're going to use this sign to show that we're shrinking our graph, and then this would be 40, and that's 50. That is 60, 70, 80, 90, and that's 100. And then for our cumulative frequency x's, we're going from 0 to 120. Let's just count how many boxes we have. We've got 1, 2, 3, 4, 5, 6, and 7. Okay, so let's move in intervals of 20. This here should be 0, 0, 20, 40, 60, 80, 100, that's 120, and that's 140. Let's label the first point. So that's 40, 0. 40, 0 would be this point over here. And then the next point is 60, 14. 60, 14 would be, this is 2, 4, 6, 8, 10, 12, 14 would be here. That's 14 over there. And then our next point is 65, 38. Okay, 65, 38 should be over here. That's 65, 38. And our next point is 70, 60. 70, 60, that's right here. The next point, 85, 106. 85, 106. So 102, 104, 106 would be here. That's 85, 106. And our final point is at 100, 120. So that's over here. And then let's join our points, trying to make an S-shaped graph. So something like this. Something like that. This would be our cumulative frequency curve. Now let's move on to part B. It is found that 35% of the students weigh more than W kgs. Use your graph to estimate the value of W. Okay, so using our graph, we can't really find the weight of more than W. It's easier for us to find the weight of less than. So if they're saying 35% weigh more than W, it means that 65% must weigh less than W. So we'll use that logic to say we have a total of 120 students, so we want 65% of them. So that's 0.65 times 120, 0.65 times 120. That gives us 78 students. So 78 students. So let's come to our cumulative frequency x's, and we'll go to 78, which is here. Draw your construction lines, and we have to go up to our curve. Try to be as accurate as you can, and then from there go down, going down until you get to the respective weight. So in this case, we can tell that our weight is 75 kilograms. Use the value that you get from your cumulative frequency graph, the one that you sketch. Read off the exact value you get from your construction lines. That should be your answer. So in our case, W is equal to 75 kgs, and that would be our final answer. Part C. Calculate estimates for the mean and standard deviation of the weights of the 120 students. Okay, to be able to do this, we need the midpoints of all the classes we were given in Part A, midpoints against their frequencies. So this would be frequency. So let's start by getting the midpoints of each class. So for the first class, 40 is our upper bound. They didn't write 0, but you should know that this class is starting from 0 and it's going up to 40. So the midpoint of 0 and 40 is 20. So that means for our first class, our midpoint is 20. And then for our next class, it's going from the upper bound of the previous class, which is 40, up to 60. So midpoint of 40 and 60, that's 50. So this is 50. And then let's move to the next one, which is 60 and 65. That's 62.5. 62.5. And the next one, that's 65 and 70, which is 67.5. So that's 67.5. And then our final class, no, rather our second from last, that's 70 and 85. And half of that would be 77.5. So that's 77.5. And then for our final class, that's 85 and 100, which is 92.5. 92.5. And then we also need to find the frequencies. Notice that we're given the cumulative frequency, so we have to work backwards and get our frequencies. So for the first class, it's 0. Our frequency would be 0. And the second class, it would be 14. And basically how we're getting these values is the class that you are currently on minus the previous class. So for the second class, we said 14 minus 0, we got 14. So for the next class, it's 38 minus 14. So 38 minus 14, that is 24. 24. And then let's go to the fourth class, 60 minus 38, which is 22. That's 22. And then the next class, that is 106 minus 60, which is 46. So that's 46. And our last class is 120 minus 106, which is 14. Now that we have our midpoints and our frequencies, we can now evaluate both mean and standard deviation. Let's start with our mean. X bar, the formula we're going to use, is equal to the summation of xf over the summation of f, where x are the midpoints and f is the frequency. So in our case, that would be, in fact, let me write it on the next line. So this would be x bar is equal to 20 times its frequency, that's 20 times 0, plus 50 times 14, plus 62.5 times 24, plus 67.5 times 22, plus 77.5 times 46, plus 92.5 times 14. And this should all be over our cumulative frequency, 120. And x bar is equal to, let's punch this into the calculator. So that's 20 times 0 plus 50 times 14 plus 62.5 times 24 plus 67.5 times 22 plus 77.5 times 46 plus 92.5 times 14, and this is all over 120, so that gives us 1709 over 24. 1709 over 24. This is our mean. Now the formula for standard deviation is the square root of, that's the summation of x squared f over the summation of f minus our mean x bar squared. So now let's start by finding the summation of x squared f first. So the summation of x squared f is equal to, so it's 20 squared times 0 plus 50 squared times 14 plus 62.5 squared times 24 plus 67.5 squared times 22 plus 77.5 squared times 46 plus 92.5 squared times 14. That's summation of x squared f. Now let's punch that into the calculator. So that's 20 squared times 0 plus 50 squared times 14 plus 62.5 squared times 24 plus 67.5 squared times 22 plus 77.5 squared times 46 plus 92.5 squared times 14, and this gives us 625,062.5. Now let's go back to our formula and substitute. So that's 625,062.5 over our total cumulative frequency, which is 120, minus the mean squared 1709 over 24, and this is squared, so sigma is equal to, let's punch this into a calculator, that's 625,062.5 over 120 minus 1709 over 24 squared, and that gives us 11.8, correct to 3 decimal places. So that means x bar, therefore x bar is equal to 1709 over 24, and sigma is equal to 11.8, and this would be our final answer. Number 5. The probability that a driver passes an advanced driving test is 0.3 on any given attempt. Part A. Deepak keeps taking the test until he passes. Random variable x denotes the number of attempts required for Deepak to pass the test. Okay, so the key word here is until. This gives it away that this is a geometric progression. So it means that x follows a geometric distribution with the probability of success being 0.3, and we want to find the probability that x is between 2 and 6. And so this is the probability that x is equal to 2, 3, 4, 5, and 6. So that would be equal to the probability of failure 0.7. That's to the power, let's start with when x is 2. So that's to the power 1 times 0.3 plus 0.7 to the power 2 times 0.3 plus 0.7 to the power 3 times 0.3 plus 0.7 to the power 4 times 0.3, and lastly for x is 6, that's 0.7 to the power 5 times 0.3. And now let's punch this into the calculator. So that would be our answer for the probability that x is between 2 and 6 inclusive. So that's 0.7 times 0.3 plus 0.7 squared times 0.3 plus 0.7 cubed times 0.3 plus 0.7 to the power 4 times 0.3 plus 0.7 to the power 5 times 0.3, and this gives us 0.582 correct to 3 decimal places. 0.582, and this would be our final answer. Part 2. Find the expectation of x. So the formula for expectation of x under a geometric distribution is 1 over p. So that will be 1 over 0.3, which simplifies to give us 10 over 3. So the final answer would be the expectation of x is equal to 10 over 3. Let's move on to the next part. 5 friends will each take their advanced driving test tomorrow. Part B. Find the probability that at least 3 of them will pass tomorrow. Okay, so let's define our random variable as the number of friends that pass. Number of friends who pass driving test. Who pass driving test. And the number of friends is fixed to 5, so this means that this is a binomial distribution. So that's 5, and our probability of success was given in the stem as 0.3. And now we want to find the probability that at least 3 of them, so that's the probability that y is greater than or equal to 3. Okay, so now let's use the formula for binomial probabilities to solve this. This is y should be equal to 3, 4, or 5. So that's 5, choose 3 times 0.3 to the power 3 times 0.7 to the power 2 plus 5, choose 4 times 0.3 to the power 4 times 0.7 plus 0.3 to the power 5. Let's punch this into a calculator. That's 5, choose 3 times 0.3 to the power 3 times 0.7 squared plus 5, choose 4 times 0.3 to the power 4 times 0.7 plus 0.3 to the power 5, and that gives us 0.163. The probability that y is greater than or equal to 3 is equal to 0.163, correct to 3 significant figures. 75 people will take the advanced driving test next week. Part C. Use an approximation to find the probability that more than 20 of them will pass next week. Okay, so let's define our random variable. This is number of people who pass driving test next week. So D follows a binomial distribution, and N is 75 and P is 0.3. Now we've been told to use an approximation. At AS level, the only approximation we use is the normal approximation to the binomial distribution. But if you wanted to verify if this is the correct approximation, you can simply check if NP is less than 5 and if NQ is less than 5. So this means D now follows a normal distribution with mean NP and variance NPQ. So let's find NP and NPQ. So NP is equal to 75 times 0.3. So 75 times 0.3 gives us 22.5, 22.5. And NPQ is equal to 75 times 0.3 times 0.7, which gives us 75 times 0.3 times 0.7. That gives us 15.75. So that's our variance. This means that D follows a normal distribution with mean 22.5 and variance 15.75. We are required to find the probability that more than 20 of them will pass next week. So the probability that D is greater than 20. But remember that we're coming from a discrete distribution going to a normal or continuous distribution. So in a continuous distribution, 20 represents 19 any number between 19.5 and 20.5. Since we want greater than 20, we don't want to include 20, so we'll start from 20.5 going upwards. So it means we want the probability that D is greater than 20.5. And now let's standardize. So this becomes the probability that Z is greater than 20.5 minus 22.5 over sigma, which is root 15.75. Let's punch that into our calculator. That's 20.5 minus 22.5 over root 15.75, and that gives us negative 0.504. Negative 0.504, and this can be written as phi of 0.504. Read off the value from the normal distribution tables and you get 0.693, and that's our final answer. Number 6. Jay and his wife Kaz are having a party. Jay has invited 5 friends and each friend will bring his wife. Part A. At the beginning of the party, the 12 people stand in a line for a photograph. Part 1. How many different arrangements are there of the 12 people if Jay stands next to Kaz and each friend stands next to his own wife? Okay, so we've got Jay and Kaz standing next to each other. Then we've got friend 1 with their wife, we'll call that wife 1, friend 2 and wife 2, friend 3 and wife 3, friend 4 and wife 4, and finally friend 5 and wife 5. So we can tell that we've got 1, 2, 3, 4, 5, 6 groups. So we can rearrange those 6 groups in 6 factorial ways. Then notice that in each group we can swap the order of the wife and the husband. So for example, in the first group where we have J and Kaz, we can rewrite it as K and J. So that would be times 2. But we can also do the same thing for all other 5 groups. So that means in total we'd be multiplying by 2 6 times. So we can just write this as 2 to the power 6. And let's punch that into the calculator. That's 6 factorial times 2 to the power 6. That gives us 46,080, and that's our final answer. Let's move on to part 2. How many different arrangements are there of the 12 people if Jay and Kaz occupy the 2 middle positions in the line with Jay's 5 friends on one side and 5 wives of the friends on the other side? Okay, so we've got Jay and Kaz in the middle. Then we've got the 5 friends. So let's do friend 1, friend 2, friend 3, friend 4, friend 5. And then their wives on the other side. So that's wife 1, wife 2, wife 3, wife 4, and finally wife 5. So on the left hand side, we've got 1, 2, 3, 4, 5 friends, and those friends can be arranged in 5 factorial ways. And the same goes for the 5 wives on the right hand side, so they can also be arranged in 5 factorial ways. And notice that J and Kaz, they should be in the middle, but they didn't specify which order. So we can swap J and Kaz so that Kaz comes first and then J. So that's multiplied by 2. And also they didn't tell us that the 5 friends have to be specifically on the left hand side and the wives on the right hand side. So that means we can actually swap these two groups so that the wives are on the left hand side and the friends on the right hand side, and for that reason we multiply by 2 again. And so if we punch that into the calculator, that's 5 factorial times 5 factorial times 2 times 2, which gives us 57,600. And this is our final answer. Part B. For a competition during the party, the 12 people are divided at random into a group of 5, a group of 4, and a group of 3. Find the probability that J and Kaz are in the same group as each other. Okay, let's create an expression for our problem. We're saying J and K are in the same group. So we want the number of selections in which J and Kaz are in the same group divided by the total number of selections when there are no restrictions. So let's start by finding the number of selections in which J and Kaz are in the same group. So let's start with the scenario where both J and Kaz are in group 5, the group of 5. So that's 5 slots, 1, 2, 3, 4, 5, and 2 of them are occupied by J and Kaz. Then we have a group of 4, 1, 2, 3, 4, and then a group of 3, 1, 2, 3. For this scenario, we can tell that we have 3 remaining slots in the first group of 5. And since J and Kaz have already been selected, so that means 10 total people remain, and we want to select them into 3 slots. Then if we go to the next group, we've already selected 5 people in the first group, so it means a total of 7 people will remain, so that's 7 choose. We've got 4 slots, so that's choose 4. And then after we select the 4, it means 3 will remain, so that's 3 choose 3. If we simplify that, that's 10 choose 3 times 7 choose 4 times 3 choose 3, and that gives us 4,200. Okay. Now let's move on to the second scenario where J and Kaz are in the group of 4. So we have 5 slots in the first group and then 4 slots in the second group, and 2 of them are taken by J and Kaz, and then we have 3 slots in the final group. So since J and Kaz are already selected, it means only 10 people remain, and we have 5 slots available in this group over here. And then since 5 people have been selected and J and Kaz have also been selected, it means only 5 people remain from the 12. So that's 5 choose, and in this case we have 2 slots available here, choose 2, and now 3 people remain for 3 slots. So let's punch that into the calculator. That's 10 choose 5 times 5 choose 2 times 3 choose 3, which gives us 2,520. Now let's move on to the group of 3. So in this scenario, J and Kaz are in the group of 3. So that's the group of 3, J and Kaz are here. And that means we have 10 people going into 5 slots. And then we've got, in this case, we've selected 5 and both J and Kaz are out of the selection pool, so that means only 5 people remain, and in this group there are 4 slots available, so that's 5 choose 4, and then finally 1 choose 1 because there's only 1 slot remaining for 1 person. If we punch that into the calculator, that's 10 choose 5 times 5 choose 4 times 1 choose 1, which gives us 1,260. Let's tally up the results from all 3 scenarios. That's 4,200 plus 2,520 plus 1,260. Punch that into the calculator. 4,200 plus 2,520 plus 1,260, and that gives us 7,980. And these are the total number of selections in which J and Kaz are in the same group. Now let's find the total number of selections when there are no restrictions. So we have our group of 5, our group of 4, and then our group of 3. We've got 12 people and we're choosing into 5 slots. Since we've selected 5 people already, it means 7 people remain and we're choosing them into 4 slots. And now only 3 people remain for 3 slots. If we punch that into the calculator, that's 12 choose 5 times 7 choose 4 times 3 choose 3, which gives us 27,720. 27,720. These are the total number of selections when there are no restrictions. Now let's find the probability that J and Kaz are in the same group as each other. So that becomes 7,980 over 27,720. If we punch that into the calculator, that's 7,980 over 27,720. That gives us 19 over 66. 19 over 66. Therefore, our final answer is 19 over 66. I believe that's the final question. So that's it for today's breakdown. If you enjoyed that, please like and subscribe and comment down below which paper would you like to see me break down next. Bye bye.